All right, so welcome back, everyone. We're going to continue looking at section 2.5. We're working towards a linear regression. If you remember last week, we looked at lines of best fit. We talked about correlation, if it's a positive or a negative correlation, or if there's no correlation. So we looked at some general information. Today, we're going to look at how you can calculate a line of best fit, which is also called a linear regression equation by hand. I'll be honest with you, I'm going to show you later this week how you can use Desmos, and that'll be a little bit more accurate than what we're doing today. But I still think it's nice to know how to do this if you didn't have access to the technology, depending if you're in a class where they let you use stuff or not. So it's going to review some of the stuff we saw with the lines we're going to see. But the first thing we're going to kind of look at is making our scatter plot. So if you look at this, it says given below are different types of food along with numbers of calories and grams of fat contained in them. So you can see like in this chart, we've got different types of food, the number of fat in them, and then the calories as well. One tip, it kind of tells you in number one below, but if you have a horizontal table, your first row is your X variable, the second row is your Y variable. And obviously, if you see a table that's vertical, remember your left column's your X, the right column's your Y. So just keep that in mind, though, with a horizontal table, it's the first row is your X variable, the second row is your Y variable. So if you look, the first thing they're going to ask us to do, number one, is using the data, we want to graph these on our graph sheet. So if you have this kind of to the side, this is our 2.5a graph, and that's what note sheet we're looking at. So we just want to plot our points, but before we even start plotting, you want to label your axes. So your x-axis always goes on the bottom. So if you remember from that table, that was our number of fat grams. And then your y value goes along the side. So our y value was the number of calories. And I've already got the numbers labeled for you. Sometimes you might have to kind of come up with that on your own. We'll see if we get there, but just usually not too bad to just come up with something that fits in your graph. But we just want to plot our points. So we got our first point is 0, 0 for water. Corn is about 183, so that would be slightly over, be about here. So we're just approximating, but 183, if you look like this is 5, this is 100, so it'd be slightly over, not quite up to the 100 mark. And like I said, we're making a very rough sketch. The next one is burger with cheese. We got 14, 324. So 14 on the X value would be about here. 320 something would be slightly above there. So approximately there for sketching. Okay, our next point is a big Texas. That's 20, 400. So over 20 up 400 would be exactly on this corner here. Our next thing is chocolate milk. That goes 8. 208, so if we plot 8 would be a little bit before the 10 on the x-axis, 208 would be slightly above the 200 mark, so maybe somewhere around there. Grilled chicken is 161, so that'd be partway, almost halfway, a little bit past halfway on the 0 to 5. Up to 161 would be approximately here. 40, and then the last one, hot fries, is 48, 840. So 48 would be a little bit before the 50 and all the way up to 840. It might look something approximately like this. So before we even continue, like I'm just thinking, what type of correlation is this? Is our data going up? Is it a positive trend? Is it a negative trend? And do you think it would be, how closely related do you think this would be? If you thought about that, it would be strong positive. I'm sorry, I didn't mean to like go back and forth. So this was our graph. What they tell us to do, if you look at this number one, they tell us to pick, they're going to pick 2 points. Sometimes they might say pick 2 points on your own, but basically the draw your line of best fit, a lot of times you just use 2 data points. So they want us to connect water and the big Texas point. So just to kind of remember which points those were, I'll kind of like highlight them. Water was down here, big Texas was here. So they want us to draw a line of best fit. So we'll see how good I can do. You might want like a ruler or use something as a straight edge, but our line of best fit might look something like this. If I connect it between those 2 points, you can see all the points are pretty close to my line of best fit. So I would say this is probably like a strong positive correlation. So that's our first step. The next thing they want us to do is figure out the equation of this line of best fit. So this is where we're going to review a lot of our skills we've seen with lines in previous sections, like 2.3 and 2.4. But first thing we want to do is find our slope. So if we just kind of label x1, y1, x2, y2, if we just kind of plug in our slope, it'd be 400 minus 0 on the top, 20 minus 0 on the bottom. If you just work that out, I mean, if you subtract 0, nothing really changes. If you divide this out, you would see the slope simplifies to be 20, if you like simplify that fraction. So that's our m. The next thing they want us to do is to find our new b. So remember, to find our new b, you use that y equals mx plus b formula. You're going to plug in your slope. So we just found our slope was 20. Then you can use either one of these points as your x and y. Personally, this first point's nice. It's always nice if you plug in zeros, in my opinion. But if you plug in 0 for x and 0 in for y, we can solve this equation for b. I mean, 20 times 0 would just be 0. And then 0 plus b is just b. But I mean, if you subtract that 0 over, you're just going to get b equals 0, right? So once you get your m, once you get your b, you can write the equation of our slope, like of our line of best fit we just drew. So our slope would be 0x, oops, sorry about that. And then our b was plus 20. So, and you could even simplify that. 0x would basically go away. So we basically have the line y equals, oh wait, I plugged those in the wrong spot. I apologize. Sorry about this. So sorry, the m should have went with the x part. So sorry, it'd be 20x plus 0 was our b. So sorry about that goof. But basically you would see that 0 would basically go away. So it'd be y equals 20x is basically our equation. And if you look at your graph, sorry to kind of switch back and forth, you would see that that slope would, this line does start at 0, and the rise over 1 would be, it's going about 20 over 1. That might be hard to see on your graph, but like that's what the line you just drew, that's the equation of it between those 2 points. So like I said, why do you even want to come up with this line of best fit, or this linear regression equation is another word we use for it? Well, it lets you make different predictions. So let's just look at a couple examples. The first thing you always want to be careful about, so they said, using your equation, find the number of calories in a slice of bacon that contains 3 grams of fat. So first thing you always want to pay attention to, what variable are they giving you? So if you remember, grams of fat is an x value. So we're going to use the equation we just came up with, y equals 20x, and we're going to plug in 3 for x, because this is an x value. So we would just have y equals 20 times 3. That would be 60. So there would be 60 calories. If you remember, y is the number of calories. So it'd be, you would expect there to be about 60 calories in this slice of bacon. Using your equation, number 6 says, find the grams of fat in an order of chicken nuggets that contains 306 calories. So this is a y value. If you remember looking up here, this is calories. Oops. Calories is a y value. So we're going to use the same equation, y equals 20x. Oops, my bad. And we're going to plug in 306 for y, though, and we're going to solve for x. That will tell us the number of fat grams. So if you divide this in a calculator, 306 divided by 20, you get approximately 15.3. Well, no, you get exactly 15.3. Sorry. So that would be the number of fat grams. So you, in these chicken nuggets, you would expect to have about 15 grams of fat. So that's basically the idea. You're going to have a practice sheet where you're going to sketch your scatter plot. You're going to come up with an equation. You're going to plug it in to find a couple different values. But when you're plugging in these numbers, just make sure you check before you plug it in what variable it would go with. Are they giving you an X value or are they giving you a Y value? Because that's very important, because you might get the wrong answer if you don't plug it in the right place. So just be on the lookout for that. But let me know if you have any questions. I hope this video was somewhat helpful. Sorry for some of the goofs.